Let's learn Docker and containerization. First of all, once you have your container runtime ready, which is Docker in our case, you open a terminal. You open a terminal and Docker run the image detached. Oh, it's not visible here. That's better. Detached mode, which means that it will run on the background and that split everything in our terminal. So just run silently. Ports. So we're going to bind the port 80 of our local machine, so our localhost 80, to the port 80 of our container, and then we'll specify our image name. I'll use the default Docker tutorial image. Docker. Getting started, and just hit enter. So it says that it couldn't find it locally, so it's going to use it. So it's going to pull it from Docker Hub, which is the biggest and official Docker container registry. So here we have it running, and if we check our Docker images, first of all, this is the desktop app. We're going to install it later. So you won't have all of this. You will just have this Docker getting started, which we just pulled. And you can see how heavy it is. So here you see that it's running because we set to run it. And it's running on port 80 of our local machine. So if we check our port 80, here you see localhost port 80. This is the official tutorial of Docker. We'll walk through the important steps of this tutorial as well. So the things that you need to know. All right, back here. So we did the demo. Next, we'll explain what containerization is as well as Docker. Then we'll install Docker, and then we'll just get a basic understanding of containerization and Docker. First, we need to understand the difference between virtual machines and containerization. So on the left side, we have virtual machines. And you see that the stack goes like infrastructure first, so your hardware, then the hypervisor, and then you have different operating systems, which can be anything. It can be Windows, Linux, Mac, anything. And those operating systems contain your app. They have well-defined resources. And this is kind of slow, much slower than the containerized apps. So in containerized apps, you have the infrastructure, and then you have one operating system, which can be a Linux operating system with a Linux kernel. The kernel is very important because all your apps are going to be using this kernel. So if this kernel is a Linux kernel, your apps can be Linux-based apps and not Windows-based apps. Docker is a container runtime that uses operating system level virtualization to deliver software in packages called containers. Containers are isolated from one another and bundle their own software, libraries, and config files, so they have everything they need in order to run independently of anything else. Docker can package an application and its dependencies in a virtual container that can run on any Linux, Windows, or Mac OS. But remember, the base operating system matters because it's its kernel that will be used in the applications. So you can't run a Windows container in a Linux host. Containers can communicate with each other through well-defined channels. So normally containers are isolated, but you can make it so that they communicate with each other. The standardized environment. So you have all these developers who have different machines with different environments and different dependencies. And what works on one machine can fail to work on another machine. But with Docker, everything is standardized and you just have a Docker file. And if it runs on your Docker machine, it will run on any Docker machine. Responsive deployment and scaling. So Docker containers are meant to be disposable units. You can create new containers and destroy your previous containers many times without causing any trouble if you're doing it right again. Then we have running more workloads on the same hardware. So you can have different parts of your app depending on different versions of different dependencies. And you can just have individual containers with different dependencies and with different versions. And they won't really collide because they don't communicate, they were isolated. So you can have one container depending on an older version of a dependency, while the other one depends on the latest version of that dependency, run on the same machine without causing any trouble, which is great. The Docker architecture, you have the client, a host, which can be on the same system, and the registry, which by default is Docker Hub, but you have others as well. Basically like GitHub, you pull official images. Any kind of image, you can build your image, and the client just makes some requests, and the Docker daemon does all the heavy lifting. let's install Docker. First, we have the online version, which is good, but not as fast as the local version. We're going to install the local version here. So let's go to the link here. And just click on your machine, minus the Windows. Okay, so first of all, you have to check the requirements here. You need a 64-bit processor, at least 4 gigs of RAM, but I recommend more, way more. BIOS level hardware virtualization. So the way we have to do this is first go to the BIOS, and then go to Advanced, go to CPU, and check Enable Hyper-V, which is a virtualization feature, and we need that for our installation. So once you've done that, come back here, download your Docker desktop for Windows, and just click install, and it will guide you through the steps. And once you're done, you will have this thing running here, which is the Docker desktop. And this thing actually uses a Linux kernel because we installed Windows subsystem for Linux. So we can install Ubuntu, Alpine, and everything else on our images and containers, which is good because those are the most common images. All right. Once you have this running, just open the terminal and run this command you see on your Docker desktop. And you should have the same thing as me. And here you have the, you can open it on the browser. You can open a CLI into it. You can stop it, you can restart it, and you can delete it. Here you should have this. And you have different options here. Anyway, let's get back here. All right, so here's a list of useful commands. These are the commands you will use a lot. So the most common used command will be docker build -t, which is --tag, same thing. So it's the name of your image. So when you're building an image, you give it a name. And here, the image name is my image. And the dot basically means that there's a Docker file in the directory you're executing this command from. So next command is docker run. Docker run -d means detached. It means do not print everything that the container is doing into my current shell. Just do it in the background. -p means port, and first one is host port. Next is the container port. So here in this case, the container is called my image, and it is listening on port 8080, and we bind that to our port, our localhost port 80. So when we go to localhost port 80, we're basically going to containers port 8080. Other ones are docker pull, docker push, just like it. Docker ps, process status, it will list our processes. Docker stop start, docker remove, and docker run it. This is not the same as the previous one because we're running in an interactive mode, interactive shell mode it's called. And you do this by specifying -i and -t, which I stands for stdin, which means that keep track of what I'm inputting and execute those in the container. And -t means this is your teletypewriter. It means basically your current shell becomes an interactive shell for the container inside the container. And then have docker exec with a container ID, then a command and command arguments. These are the most common ones you will be using. All right. Next in line is Docker files. These are also important. So Docker files basically removes the CLI complexity. The CLI is what we saw previously. But Docker builds things in layers. So you see, for example, here a Docker file. The way Docker works is it will build everything in layers, and as soon as something changes, it will rebuild it starting from that layer. And we'll see how to optimize that later. So first and most important thing in a Docker file is from. From will initialize a new build stage and set the base image for subsequent, I don't know how to say that, subsequent instructions. So it's the start of a new chain of commands. You have a couple of examples on the bottom. From Alpine, which means pull an image of Alpine. If you don't specify the version, it will pull the latest one, and all the subsequent commands will be executed on top of that image. You can have an Alpine with Node installed, with Node 12 in this case. You can have Python. All right, next we have run. So run is another very common command. The run instruction will execute any commands in a new layer on top of the current image and commit the results. resulting committed images will be used for the next step. So run is basically a part of your building process, which has two different forms. The first one is the shell form, which is basically run and then you specify a command, such as print working directory pwd. This command is run in a shell, which is by default bin shell command on Linux. The second one is an executable form, which you can see because it's in an array with double quotes. First you have the executable, then you have the parameters. They must have double quotes, by the way. So to clarify, let's check the examples. Run yarn install. This is a shell form. The next one, pip installer requirements, also a shell form. And next you can see it's an array with double quotes. So it will basically execute the bash, then command, then echo hello. And also the shell form does not invoke a command shell, so no processing. For example, no environment variable substitution, which is done by the shell. So here we have a similar instruction, the CMD. The main purpose of CMD is to provide defaults for an executing container. These defaults can include an executable, or they can omit the executable, in which case you must specify an entry point instruction as well. We'll see entry points and CMDs soon, but they work together. What's important to note is that there's only one CMD instruction in a Docker file. 3 different types. The first one is the preferred one, is the executable form, where you specify in an array with double quotes the executable and then the parameters. And you can also use it as a shell form. And we'll see how these work soon. But first we need to compare run and CMD because they're pretty similar, right? So run is an image build step. So you can have many different run steps in a building process, where CMD is the command the container executes by default when you launch the build app. So one CMD which is executed once the container is launched, and it's not part of the building process. Next, expose. This is a type of documentation. The expose instruction informs the Docker that the container listens on the specified network ports at runtime. So by saying expose port 80, you're basically telling the developers who will run your app that the run command must bind whatever port of their local host they're binding into the port 80 of the container. Environment variables, you know these. Add, okay. The add instruction copies new files, directories, or remote file URLs from a source and adds them to the file system of the image at the path destination. You can have wildcards. Copy, very similar. The copy instruction copies new files or directories from a source and adds them to the file system of the container path destination. But what are the differences? Add vs copy. Well, the major difference is that add can do more than copy. And you should use copy if add isn't required. Add basically allows the source to be an URL, and if it's a tar file, it will just unpack it as a directory. All right, entry points. Entry points are important. You have 2 different forms: the executable form and the shell form. The executable form is the preferred one, the green one. An entry point allows you to configure a container that will run as an executable. Command line arguments to Docker run image will be appended after all elements in the executable form entry point. So if you have an entry point in an executable form, and then you have a Docker run my image with some args, those args will be appended to the entry point, and that will override all elements specified in the CMD. This allows arguments to be passed to the entry point. For example, Docker run image -d will pass the d argument to the entry point. The shell form prevents any CMD or run command line arguments from being used. And this whole thing will be much more clear in 2 slides. Just wait for it. So here you have 2 examples. First one is the executable form. The command from the CMD will be appended to the entry point upon execution. The second one is a shell form. The CMD is not used. Same for the run command line arguments. So the CMD and entry point interaction. Both CMD and entry point instructions define what command gets executed when running a container. Docker files should specify at least one CMD or entry point commands. Entry point should be defined when using the container as an executable. CMD should be used as a way of defining default arguments for an entry point command. And those default arguments in the CMD can be overridden when you type Docker run my image and specify some arguments. Those arguments will replace CMD. All right, so this should clarify everything. On top, you have the entry point, and on the left side, you have the CMD. So if the entry point is in shell form, it will overwrite all Docker run arguments as well as all CMD arguments. If the entry point is an executable form, which is better, it will just have the CMD appended to it. These are the entry point commands. So here you have the 2 entry point commands and the 2 CMD commands. Same here and same here. And because the CMD here is in shell form, you have the bin shell command appended to the CMD command. All right, the last one is the work directory. This basically says the working directory for any command that follow it. And it's quite straightforward. Quick view of the official tutorial. So here, when we open our Docker runtime, we see that our getting started app is running. And just click on this. So we're just going to see the important parts of this tutorial. Basically, in this tutorial, you just download an app and then you build the Docker image, which is Docker build. You tag the image with getting started, and then you specify the path to the Docker file. And this is your Docker file. So here in our Docker file, we have an Alpine Linux with Node 12 in it. So the app is a Node environment app. Then we have a run command for our Alpine. And then we specify our work directory. So basically create a directory inside the Alpine. So then you copy everything from your apps directory into the container. And then you run an installation command. So basically install all the dependencies in production mode. And finally, the CMD, which will basically launch our app. So once you build it, you just docker run detached port, specify your port, specify the port of the container, and specify the name of the container, and it's running. So how do you update the app? Well, imagine you change something. Well, then you build it again. And then you have to remove the previous one. To share your app, you can create a Docker Hub account if you want. There are also other container hubs. Create a repository with a name and set it to public. So before you can push it, you have to change the tag and make it your username dash your image name. And you can do that with Docker tag, your previous image name, your new image name, which has your Docker Hub username, and then the image name. And then you just specify Docker push and the full path. And then you can just, in a different machine, Docker run detached port. And then you specify your username and the image name. All right, so here we'll talk about volumes. So right now, when you delete a container, all the data in it is lost. And you can use this thing called named volumes. And the way it works is like this. So here you have a Docker volume, create your volume name. And this is called a named volume. And the way it works is basically you tell Docker to create a volume somewhere in your machine. And then you can use this volume to mount it into your containers, into a specific path of your containers, so that the data that the container creates in that path of his is actually saved to the mounted volume and not destroyed when the container is destroyed itself. And the way you mount this volume is like this: Docker run, just normal run, and then you say -v is a volume. Specify the name of the volume, and then 2 points to mount it into this path of the container. So anything that gets saved here is actually saved here and not destroyed when the container ends. And this is the image name, of course. So again, this is called named volumes. Let's go next. Bind mounts. This is very similar to the previous one. And you can see that here the differences. Host location. When it's named, like the previous, Docker chooses where it's going to store it. When it's a bind mount, you choose what location to bind to what other location. So both mounts are triggered with a -v command. And here it's a name, not a directory. 2 points, directory in the container. And when it's a bind mount, it's a directory binded to a container directory. And then a named volume will actually populate new volume with the container contents, whereas the bind mount will not populate with the container contents. So one way to use the bind mounts would be to start a dev mode container. Basically, you have your app in your machine that you want to actually run in dev mode in your container. So before we run this command, we have to be in our app folder. So what this will do is basically run our development mode. All right, so what this will do is basically run our development mode in the container. So when we change a file, the container will basically refresh it. The way it works is like this. First of all, we have an Alpine image with node 12 in it. And then we run it on port 3000. Then we specify the working directory at /app. And then we say -v, which is volume. And here we specify a path, which makes it a bind mount because it's not a name, it's a directory. So this command will basically mount the app from our current working directory into the container. So our current working directory is what the container's app sees. And then we make it install the dependencies and run the development mode. And the development mode will basically look for changes in the files. So when we change our local files, the container sees those changes, and the yarn run dev will basically update the app, which we can see in our local browser. All right, so I'm not going to be talking about multi-container apps, because if you're dealing with multiple containers, you will probably be using a container orchestration system such as Kubernetes, which is the most popular one. And I'll make a video about that. Next, so let's check the best practices. First one, you can scan your image, of course, sure. And another thing is you can check the layers of your image and how much space they take each. So if you type Docker image history, this is a command, and then your image name, you will see that each step and how much space it takes. And then we can use this thing called layer caching. So this is the first Docker file we had. So here we have our Alpine base, our working directory. We copy everything, then we install it, and then we run it. But because building is done in different steps, when you modify a step, all the steps below it are rebuilt. And our dependencies get modified less frequently. So it would make sense that our app is something like this. First, our Alpine image, then we specify the working directory, and then we copy our package, and then we install everything. And after that, we copy everything. And of course, here we don't want to copy our node modules again because they're already there. So what we can do is just create a file, just like a git ignore. It's called docker ignore, and you type in node modules in there. And when you say copy everything, it will copy everything except the things specified in the docker ignore. So this way, when you change something, only this part changes, and this part is cached. So it goes faster and it's better practice. And then you can also have multi-stage builds, but this is more advanced and more specific, so we'll not cover this. All right, it's done. So now you should have a better view of Docker and containerization. So tell me if you learned something, and until next time, bye.